So some of the first things that we want to talk about today is about the radiation of the sun. So we're going to say the sun is out here, obviously, and all of this radiation comes in. The first thing that we need to look at here is that radiation that comes in. So our atmosphere acts like this little shield, and there's a reason why I did this the way I did, is so that it would all be uniform. If I did it by hand, it wouldn't be so uniform. This way I can show you some better things. So we have the sun, and we bring that sun in here. And if we take a look at this, we have sunshine coming in, and this is the surface. This little area here is our actual atmosphere. The sun at the equator, if it comes up there versus over here, that looks fairly level. Okay. Why does the Earth heat unevenly? And a lot of people that I have talked to, unevenly, I'm thinking of heat, evenly. A lot of people think because right here they're actually physically closer to the sun versus here, that's why it's warmer here. And that's not true. I mean, we're talking maybe 1,000 miles or whatever. It's not going to make any difference. And so, technically speaking, all the way from here to here all receives 100% of the sun's radiation. There's no distinction between here and here. So, if you're up here and here, you're still going to receive the same amount of sunshine. The sun's not going to say, oh, you're up here, we're only going to give you 50%. You're down here, we're going to give you 100%. That doesn't happen. The sun's always producing the same amount of energy. But the Earth says differently. The Earth will say, oh, no, because you're up here, we're going to reduce the amount of sunshine you have. And that has everything to do with the shape of the Earth. So when we look at this part right here, number 1, the atmosphere filters out a lot of the sun's energy. So, hopefully you did some of these notes and you remember some of the things. If not, we will definitely go through them. But ozone and certain gases are really good at blocking out radiation, especially ultraviolet radiation. And we have ozone in our atmosphere. But one thing that acts just a little bit differently is to look at the distance between here and here. Yeah, so when you look at this, which one is thicker? This one for sure, right? And if they both filter everything out, well, how much filtering is going on here versus up here? Yeah, there's a lot less going on here. Because it's more direct and there's actually less atmosphere that it's going through, this part of the Earth will receive more radiation because less is being filtered out. Well, yeah, they'll receive more radiation. Up here, we'll receive less. It's almost, I think it's almost like 3 times the length of this as far as atmosphere thickness goes. So it's almost as if instead of going straight up, you go on an angle and everything gets thicker. There is, and I'm going to divide this up here. I'm going to put poles versus the equator. So when we look at filtering, poles, a lot. Equator, very little. Okay? So if there's less filtering going on, then how much energy does the surface of the Earth receive here? A lot more than the poles, okay? A lot more than the poles for sure. By far, there'll be a lot more. Okay, now another thing that we want to look at here is angle. So right here, what would the angle look like versus up here?
That's like a 90-degree angle.
That is a 90 degree, and this
Something on two.
very shallow, right? It's a very low angle. Okay, so I like to talk about this in terms of skipping rocks. If you take a rock and you throw it straight down in the water, what's going to happen? Yeah, okay. That's like doing a belly flop, right? So you do a belly flop, you know it hurts because the water absorbs all of the energy. You stop like a cartoon character hitting the water, and then you're like, bloop, 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 bloop. Then if we take a rock and we skip it on, how do we get a rock to skip? We've got to do what? Put it on an angle, right? And the lower the angle, the better the skip. There's not a lot of angle here, which means there's a lot of absorption. So right up here, angle, okay, a lot of absorption. So filtering a lot, angle is high. Okay, like 90 degrees. Yep, that's pretty much hit a brick wall. But when we get up here, the angle is low. Oh, yep. Thank you. Yep. So at the poles, it's really low, and here at the equator, it's high, which means that this is going to absorb more, and this is going to bounce a lot more off. Okay, it's going to ricochet a lot of that light off of there. Okay, so the next thing we want to look at is the amount of area that's being heated. So our third one here is area. So I'm going to do the ruler thing again here, but we're going to use the ruler's thickness and show you something else here that's really kind of interesting. So we're going to take this, bring it right here, and we're going to say this is a ray of sunshine. Okay, it doesn't matter. There is one. That's one big ray of sunshine. And we're going to do another one right here. Same thickness. Same thickness here. So this is the thickness of the ruler. Nothing has changed. Both the same amount of radiations coming in from the sun, but area changes now. Notice the area right here. That if I had a flashlight right here, and I was shining it into this area, here's our nice little flashlight. Shines in, it's going to light up this area right here. Bright or dim? Yeah. Okay. Bright or dim? Bright. Okay. But if we do the same thing up here and we have our nice little flashlight, or you want to say lightsaber, what happens to the area right here? Yeah, it increases. So if I take a flashlight and shine it directly onto the board right here, I would have a space maybe like that would be lit up. But if I take the flashlight and now turn it on an angle, I'm going to have an area like this that the flashlight's going to light up. Did I change the amount of light coming from the flashlight? No. Which one does the flashlight actually have to light up more area now? The one that's on the angle. The one that's not on an angle is going to be pretty bright. So, with this going on up here, which one is going to actually receive more heat in smaller areas? Yeah, this is like the magnifying glass. If I take the magnifying glass with the sun and have it go down to one point where I can concentrate that energy in one point, welcome to the equator. But if I pull it back away and make that area a little bit bigger, it's still receiving the same amount of sunshine, but it's not going to be as intense, and therefore it receives the same amount of sunshine, but it's spread out over a larger area. All right, So area. We know that right here it is more concentrated. Less concentrated, thanks. I keep forgetting I have. Yep, I keep forgetting I have the pull it first. Less and more. This is more concentrated and less concentrated. Okay, does this make sense? Okay, now one more thing. It's a little thing called albedo, or reflectivity. How reflective is the surface? Real. Okay, yeah, really. So number 4, the last thing is reflective. Or the word is albedo. Yep, albedo means if I have an area like this and I'm shining light down onto that, let's say that 60% is absorbed, then the albedo would be 40. So albedo tells you how much light is coming off of this. So, for instance, water has a high albedo. Okay, snow has a high albedo. I think snow has an albedo of like 90, but fresh snow has an albedo of 95, which makes a lot of sense. Old snow that's been around for a while, the sun's come out and it's actually crusted the top of it over, so it's nice and flat, which is still pretty bright. However, though, fresh snow doesn't quite look like that. If you've looked at fresh snow here, which I'm sure everybody here, it has all these little snowflakes that are...
And so they all have their own albedos.
Well, because they're angled in so many different ways, they act like a disco ball. So it doesn't matter what happens, the light bounces off. Have you ever looked at a reflector up close, like on a bicycle? Okay, it's nice and smooth, but look underneath that. Yeah, it looks like this, right? That's because if we can make a rough surface, we actually get more reflectivity off of it. Because we can actually bounce more light off of that instead of having it flat. What's more reflective? A choppy surface of water or a smooth surface of water? Choppy. If you're out and it's choppy water, you'll get burnt a lot faster on choppy water than you will smooth, glassy water. Yeah. Yeah, so if it's choppy, and it's a sunny day, you're going to get burnt pretty fast. You really will. And if it's smooth and glassy, really the best way you get burned is you actually have to be in a direct angle of the sun. So if you're not directly in that angle, you're not going to get burnt as bad. Okay, so reflectivity. What about the pole? What's up there? Snow. Snow really reflective? Yes. What about down here? At the equator? Ice! At the equator, okay. Vegetation. Vegetation, plants. I know. That's like that joke. Okay. Say slop 10 times fast. What do you do at a green light? Slow. You go. Oh, man. We know what part of the class needs more focus, right? Needs a little bit more help. Okay. Yeah, I know. It's like, huh? All right. Guys, if the Earth was flat, would this happen?
No.
No, it wouldn't. And because it's round, the poles are destined to be what? Since the Earth is shaped like the sphere, the poles are destined to be what? Cold. And The equator is destined to be what? Hot. Okay. I'm so glad I'm recording this too. Yeah, you're like, crap, that's me. Poles are cold. Equator. Why does the Earth heat unevenly? Because of one thing. Yep, that's exactly it. The answer is because we live on a sphere. Yeah, that is it. If it was any other shape, it wouldn't be this. But because it's round, I mean, it's not perfect, but it's close to being perfect. Everywhere that you walk along the surface, what happens to the angle? It always changes. And since the angle is always changing, it affects all of these things. More filtering, the angle changes, more area. And because of these things, reflectivity increases as we go up.